exercise, we discussed about the cables. Okay, networking cables we discussed. Okay, then we discussed about the NIC cards. Means every system to connect in the network, they need an interface. That is called a interface card, network interface card. We discussed about Ethernet card, LAN card, like that, right? Ethernet card or a LAN card. We discussed. So different networking cables, use it. In the networking cables, mainly I discussed about a UTP cables, right? Unshielded twisted pair cable, or we can say that is a LAN cable or a patch cable it is. Okay. So with the RJ45 connect. So first of all, guys, in networking, 2 points, networking. So in network, connectivity is important. Network is all about connectivity. To connect in the network, so just simple LAN network, you can say like this. Okay. For our network, so like we need a cable to connect, right? So to connect with the cable, so for your system, you require an NIC card, like a LAN card is required, RJ45. The cable is UTP cable. And we are connecting to the network means something we are connecting. We are using a star topology here. In the LAN network, we are using a star topology. It means our device are connecting to a centralized device. It can be a hub or a switch. To connect network, if you want to create a LAN network, if you want to create a simple LAN network, so we need a centralized device. Either it can be a hub or you can use a switch. Depends upon your network size. If you have a 3-4 computers, hub is enough because it's just lesser the cost compared to switch. Okay. If you have a bigger the network, you have a 10 computers, 20 computers, 50 computers are there. So better you should go to the switch. So I will tell the why we need a switch, why we need a hub, and which situation. Okay. So we have to connect it to a device. For connecting to a device for networking purpose. So what it is, we need an NIC, we need a cable, and what is the device we are connecting? That is either it can be hub or a switch. For example, you want to connect to outside of your network. It means maybe you want to connect it to WAN, other network. Other than your logical network, you want to connect, you need a router. Need a router. You want to connect it to internet. You need a modem. Need a modem device. You want to protect your network from external attacks. You want to protect your network from external attacks. We use firewall. Security. Okay. What is the purpose of firewall? It is protect your network from external attacks. You can filter the packets which can be hello, which can not be hello. Okay. To extend your size of the network, like a so length, you want to communicate more than your cable area. So then we use the repeaters. So like different types of devices are there, but important device what we are discussing here. Okay, this is all for a network purpose. And what is a networking purpose? Already we discussed about a networking purpose. That is, first important is IP address. This is IP address is a logical address for networking, means communication. Network, connection. Networking, communication. Okay. Network, connection, connectivity. networking. Without network, you cannot do networking. Means communication. You want to communicate in the network, you need an IP address and you need a protocols. Okay. Of course, you need an application also. Okay. So we discussed about IP address and in the list. Okay. And we discussed about cables, NIC cards. Now we will going to discuss about the devices. Then we'll come back to the protocols and these protocols and application part. So we will going to understand. Okay. So once again, so I'm adding these points here like this. What is a network? Interconnection of two or more devices. Interconnection of two or more devices is called a network connection. Okay. So in network connection, what we are there, we need a cables to connect, need an NIC card to connect, we need devices to connect. Okay. Of course, security, that is separately we can discuss. Okay, that is a separate part. Okay, these are the devices required. Networking, for communicating, we need an IP address, protocols, and an applications. So this is about it. In this one, we are going to discuss first about networking devices. Once it is completed, we'll go for this part. Okay. So what is this networking devices? Networking devices is one of the thing is hub. Hub is used for LAN communication, small network. Okay. Hub is used for a small network communications and LAN communication purpose. It's a quick note only, guys. I will explain deeply, but I'm giving some quick notes, simple points only. Okay. So that is for a easy understand and remember purpose. I'm telling these things. Okay. Hub is for a LAN communication. Okay. Switch is also for LAN communication. Switch is also for a LAN communication. Repeater, repeat the signal to communicate long distances. What is a device for repeater, guys? Our UTP cables support up to 100 meters. For example, from your source to destination, the main means for one point to another point, it is more than 100 meters. Then you have to use a repeater in between. So it repeats the signal. Switch for small and large networks. Switch is for small and large networks, LAN communication purpose. And switch also knows MAC learning, MAC address table kind of stuff. Okay, router is like a works on both LAN communication, WAN communication. Router is inter-networking device. Inter-networking device. It's communicate between different networks. Okay, what is inter-networking? Communication between different networks. Inter-networking device is your router. And your router shows the best path to reach the destination. You are in your place and you are accessing google.com, facebook.com, youtube.com, you know. But how your system knows how to reach the destination? Because once your packet is out from your router to another router, other router to other router, other router, other router, finally it will reach the destination. But between your Google server to your system, there is several routers are there. But which path is better to reach? What is the fastest path? What is the best path? Okay, so lesser routers path. Okay, best bandwidth path. Like that it will take. Router, LAN, WAN. Routers used in both LAN communication, WAN communication. Mainly when you are using different logical networks, you want to communicate between them, we use a router. And router is also inter-networking device, make a communication between different networks. Router shows best path to reach the destination. Modem is another device. It make you connected to the internet. Okay, you can get it out, sir. I have a Wi-Fi router in my home, but I do not have a modem, but I am not getting internet. Yes, of course, because your Wi-Fi router itself, it is has a built-in modem kind of stuff. If you are observed from your ISP, there is a cable, either it is optical fiber cable or a cat cable. So it is coming from outside to your home and you are connecting to your Wi-Fi router WAN port. Okay. Once you are connected and you will configure WAN configuration. Okay. In the router, it will be configured your username, password, connectivity type. You will define it. Once you define and say OK, then your router will start connecting to the ISP first. ISP verify your subscription, username and password. Your subscriber ID, it will verifies. Once it is verified, what based on your subscription is a 10 Mbps, 50 Mbps, 30 Mbps, 100 Mbps, 200 Mbps. It verifies and how much your subscription based on your payment and all. So you paid or not paid, that is everything is verified by ISP. Then it will allow you to connect it to the internet. So we are getting connected to the internet using modem through the ISP internet service provider. The connectivity cable can be your telephone cable, optical fiber cable. In certain ISPs use the local ISPs and certain type of ISPs use a normal Ethernet cables also. Okay, normal or CAT cables also they use to connect. Only thing is the way of connectivity is different from one organization to another one. Firewall already I told firewall anyway I don't explain deep explanation of firewall. I am not doing anything, but you can try firewall. Okay, so if you want I will forward firewall. What is the function of firewall? Firewall is to protect your network from external attacks. If someone is trying to enter into your network using IP address or a protocol or some port number, it is trying to enter into your network, it's block it because it's a one-way type of communication. You should communicate to outside. If you are asking someone, then you will get, like you open a Google page, you will get a Google page. But Google cannot come to you and open its page directly. Without your request, you cannot get anything from outside. Okay. If something is coming to at your network, the firewall will stop. It's like a security guard. Okay. For example, if you are in an office, you can go to outside, you can come inside. But others than your office, people cannot enter into your premises, right? Like that security guard. Guys, understand the quick points?
Yes, sir.
Okay. So here it is. We are trying to explain what is this hub. Hub. Again, what is the purpose of hub? We can create a simple LAN network with the hub. Hub is a device non-intelligent. Non-intelligent means there is no additional processing is not there in the hub. Someone may ask you a question, right? You say hub is not intelligent. Hub is not intelligent means why it is not intelligent. So it won't do any additional type of process. It does not understand what is the content in your packet. Okay. So hub you broadcast the packets to the to everyone. So here it is. I have a device like a PC, B, C. D, E, F. These are a computers. For example, I have a devices and this is hub. This is hub. For each hub, of course, there is a ports. Okay, it says look like a small box having a ports. Either ports are striped or maybe just like this. Okay. So when you are making connectivity, if connectivity is there between this device and the port, connectivity is good. The corresponding LED also blinks. The link status LED is there. It blinks. So then you can understand. So it's a connectivity is there. So what hub will do? That is the point, right? For example, A send packet to B. A do some communication to B. The packet will from your A's interface, A also having a NIC card, right? A's interface to the this port. Okay, so for example, it's a port number 1. Okay, this is port number 2, 3, 4, 5, 6, 7, 8. 8 port hub. Okay, so what it will do? It send packet to the port number 1 of hub and hub to PCB to this port. It will forward to this port. Sorry. Classroom में पहले ही लगा Please stand up, sir. पहले ही लगा हाँ One second, guys. Meeting on the sir. Classes. Okay. ठीक है sir. ఆయన మీటింగ్ ఏదో ఉంటాడు ఏది ఈ రూమ్ లో ఇదే ఇదే One second, guys. The room. Okay, can you able to hear? Yes, sir. Hearing. Okay. So here it is. A send a packet to A want to send a packet to B. The packet will go to this port first of a hub. And hub, what it will do? It send this packet to this port and this port and this port and this port and this port also. To what are the ports are connected? So it will send the packet to those ports. It means the packet is received by B and packet is received by C, say that same packet is received by D and E, and F also received the packet. So everyone is receiving. It's a packet actually for B only, but all other devices is getting the packet. So what they will do it? So they will discard the packet. They will discard the packet. They check it. It's not my destination address. They will drop the packet. They will drop the packet. A, B accept the packet because the destination is B's address only. So it will accept the packet. So that is the point of hub. Hub always broadcast the packets. Same if you want to go for another example. For example, C want to send a packet to E. C send packet to E. It means first it will go to the hub, to this port, and from this port to this port, and all other ports also. Not only the destination, it will send to everyone because it never check what is the destination address by the hub. Simply it will forward the packets directly. Okay. So F is received, E is received, D is received, A is received, and B also received same packet. But what is the packet meant? The destination is your E address. So it will take the packet. Okay. So this is how hub works. Okay. We'll go to the again the main points of hub. Hub does not understand MAC address or IP address of a packet. Hub used for LAN communication, suitable for a small networks. Why it is for a small networks? If you have a 10 computers, how much broadcast will happen? For one packet, one to one only, it is doing lot of broadcasting. But if you think you have a 10 computers, lot of broadcast means it's sending a packet to everyone, same place. You are having lot of packets. Because of this huge broadcast, it means lot of packets are traveling in the line. So what happened? The collisions will occur because the packet is also a electronic signal, right? Packet is nothing but a data packet means it is also electronic signal. And a lot of electronic signals one by one. There are a lot of collisions will occur in a hub. So what happened? So because of these collisions, packet data loss, the packet will be corrupted. Packet data loss is higher. So that's why hub is for small network like 3 computers, 4 computers. You can use hub simply. Okay. Even there is a collision, it is a lesser packet travel. So it's not a big deal for them. Okay. And compared to OSL layer, if you go to the OSL layer, as per OSL layer, it is a layer 1 device, physical layer device. Because physical layer is all about a data frame and bit stream kind of stuff on connectivity related. So, like that. Okay. So, what is a hub? Hub is not intelligent device. It does not have any separate process for understanding packets and all. It provides connectivity. That's it. It does not understand what is the MAC address or IP address. So used for LAN communication, suitable for small networks. OSI layer as per OSI layers, it is a layer 1 device. As per OSI model, it is layer 1 device, physical layer. It is important point is it broadcasts a packet to every device in the network. If A want to send a packet to B, one device is send a packet to another device, but the same packet is also go to the all other connected devices. Because of this broadcast through entire hub is a one single broadcast domain. Okay, because of this broadcast domain, and it is a single collision domain. Collisions are not separated, so the more number of collisions are occurs, and data packet list is also there. That is about a hub. Yes, understand hub? this point broadcast the packets to every device in the network. You have to respond, guys. Why you people are losing their interest
Yes, sir.
every day? Okay, next one is repeater. What is a repeater? It repeats the signal, that's it. Don't boost the signal, but it repeats the signal. So you can signal, so signal can send for a longer distances. If you see here it is, its signal will be weak after certain period of certain distance it is traveled. The repeater repeat the signal, make it as a normal actual signal, so then it will can able to travel for a longer distances. You can use hubs for repeaters also. This is the repeater and this is the hub. Of course, this is also hub. Okay, just look like this. But why I'm telling these repeaters because nowadays very less of repeaters using, and you may not been seeing. Why I'm telling a repeater? Because I can give a good example for repeater nowadays. That is a Wi-Fi extender. What is a Wi-Fi extender? For example, you have a big room, big house, 2 BHK, 3 BHK type of houses, or maybe duplex kind of houses, villas kind of houses, even in offices. What will happen? In one place only the Wi-Fi router is installed from outside. So what is the nearest place, like a hall? Okay, so they will install the Wi-Fi router. Okay, then the signal will be for nearest people only. If I install in my hall room, so it will be only for in a hall room and nearest bedroom. Only the signal is strong. For others, signal is weak. For some people, no signal also, not even 1 point. So how to place this Wi-Fi extender in between those things? It means, so here is my Wi-Fi router. This is my Wi-Fi router. And here is my laptop, for example, or maybe my tablet, or maybe my TV is here. Okay. So this is no signal area or very weak signal areas. So how to check it? First, this signal also must be available, and from here also this should get a correct signal. So this Wi-Fi extender must be between these two things. It should be balanced, not in the distance manner, signal strength manner. We cannot put this at a weak signal or no signal places. It should get a signal first of all, and this signal should be received by this one. So both sides it should be balanced in the signal strength way. So that is what is the Wi-Fi extender. Nowadays we are using Wi-Fi extenders because most of our connectivity is wireless only. Okay, guys, understand what is this Wi-Fi extender kind of stuff or a repeater?
Yes, sir.
Next device is switch. What is this switch? Switch understand MAC address. Switch learn the MAC addresses of connected devices. Switch maintain MAC address table. Switch switch maintain the MAC address table. So again, guys, switch and hubs used for LAN communication. Hub is layer 1 device. Hub is OSA layer model, layer 1 device. Switch is layer 2 device. Switch is layer 2 device. Data link layer. Example for a data link layer. Hub we use for small networks. Switches used for both small and large networks. Large number of devices we can connect using switches. Of course, for with the multiple switches we can able to connect. Okay, because every switch has a limited number of ports are there, not small but bigger. But 16 port switches are there, 24 port switches are there, 48 port switches are there, 72 port switches also there. But you have 100 computers, 200 computers. Of course, one switch to another switch to another switch, like that we can connect. So then it is become one single big signal, like a extended star topology. Can connect. We connect devices to one switch and connect that switch to another switch. We can connect another device to another switch. Again, from that switch to another switch, again, connect it to that switch only. Okay, it's like that one. Next, what is hub will do? It broadcasts the packets to every device in the network. If A want to send a packet to B, but same packet is also sent to all other devices. But here it is, it unicasts the packet. Switch unicast the packet to the destination. How it is possible? Because of this MAC address table. Switch initially broadcast the packets. It means it send a packet to every device, every connected device like a hub. Okay. So what happened here with the switch? Okay. So for example, this is also a port, empty port it is, fourth one. 5, 6, 7, and this is eighth port. A PC, B PC, C, D, E, F. Guys, this is really required attention. Okay, it's not a simple like now problem. We are listening now. Like if you are only listening, you will get a sleep. That's it. Okay. So MAT. What is MAT? MAC address table. Okay, MAC address table. What is this table? Where is this table? It is inside your switch. What is this table? What is the content of the table? It is like that has switch port number. Switch port number. Like each switch has a port number, right? So like a port number 1, port number 2, okay, port number 3, port number 4, port number 5, port number 6, port number 7, okay, port number 8. So it is 8 port switch. It has a 8 ports. Next, in the table, 2 points. One is port numbers. Next one is MAC address. Whose MAC address is it is? Whose MAC address it is? Okay. So port number 1, you can see the port number 1 is here, is connected. Port number 1 is here, is connected. See, it is a port number 1. And which device it is? A's device. Which device it is? A device. So whose MAC address is? A's MAC address. So in the switch, there is a MAC address table. It contains switch port numbers and MAC addresses. The port number, which port number is connected to which device? Okay, port number 2 is connected to the B, and B's MAC address will be here in this table. Same, port number 3 is connected to C's computer, so it says C's. Of course, fourth port is not connected to anyone, so no table at all. Fifth one, so it is like a B, C, D. D is connected to the fifth port. Sixth port is connected to lines. Seventh port is connected to lines. Okay. Actual explanation is different. I changed my explanation. So I want to make it little easier than normal complex. Guys, this learning not happen directly. I have written directly the table, but it won't happen like that. So how it is happen? So first time when devices are communicating, for example, A to B communication. Okay. So first of all, it will send packet to port number 1. A is send a packet to B. So A send a packet to port number 1. Then our switch, what it will do? It check the packet. It open the packet. What is the source address? What is the destination? Switch understand MAC address only, not IP address. Switch don't know about MAC IP address. Okay. Remember, switch is understand MAC address. Hub don't understand IP address and MAC address. Switch can understand MAC address. It can learn MAC address. So it will check the source MAC address. Source MAC address. And destination MAC address. What is the source MAC address? Is MAC address only. And it will put it in the table. Put it in the table. Next, it can broadcast. It will broadcast because initially it does not know who is B and all. So it will broadcast just like everyone. So devices will communicate each other every time the devices try to communicate to other device. Okay, other device when they are communicating. Okay, so the switch will take the source MAC address and the connected port and put it in the table. Put it in the table. So like that, it can able to create its own MAC address table. So what is the advantage of MAC address table? What is the advantage of MAC address table? Look at here. For example, B want to communicate it to C. Okay. So B send packet to the port number 2. And what is the destination? C. So the destination MAC address is C's MAC address. So what is it will happen? Where is the C's MAC address? Port number 3. It will send packet to port number 3. So C receive the packet. It does not require to broadcast. Initially, before the MAC address table is created, to create a MAC address table, it do the broadcast. Because it does not know the destination address, so it will do the broadcast. Later it is don't do broadcast. It is directly, it has a MAC address table. So it will, whenever it is received a packet from the source, it check both source address and destination address. And destination MAC address based on the MAC address table, which port it is there. It will forward the packet to that port only. That's it. Okay. So it is unicast the packets with the help of market step. Okay. Switch initially broadcast packets. Send to every device like a hopper. Switch verifies the MAC address table against the destination MAC address mapped to port number. You check the destination MAC address, which port number is mapped. If it is finds packet sent to that port, it means this letter unicast. First it will do, it check the source MAC address, destination MAC address. Source MAC address, the port number will be mapped in the MAC address table. And it check the destination. Is the destination is address, MAC address is available in the MAC address table or not. Okay, if it is available, what is the port number? It directly forward to the port number. If it is not available, it is do the broadcast. Okay, A send a packet to B. Packet went to the switch. Switch does not know where is the B. Switch broadcast packet to every device like a hopper. Switch learn MAC address of A because A is sending now. So when you are sending a packet, it contains MAC address and as well as the IP address. So switch take the MAC address of A and maps to the port number 1. So it is happens when systems or devices are communicating each other in the switch, it learn the MAC address from the source and map it to the connected port number. Okay, with the help of like that. So when they are communicating next time, so it will check the destination IP address, source MAC address and destination MAC address. So and it will send directly to the destination with the to the destination's port. So that is what switch it is. So guys, simple to understand how to broadcast the packets to every device in the network. Always it will do the broadcast. Switch is not like that. Switch may initially broadcast the packets, but later it is unicast the packets with the help of MAC address table. If you tell that point, that is enough. Switch unicast the packets with the help of MAC address table. MAC address table is created by switch itself by learning the connected devices MAC addresses to the switch port number. Like you can say in a simple words also. Guys understand what is the hub and switches major differences? Okay. Number of collisions are less. It's a port-wise collisions only happens. So total packet loss is very less compared to the hub. Okay. That's why we are using the switches for a large networks also. Okay. So it's a floating and unicasting. I told about unicast. Floating means it is like a repetition of same signal again and again. That's a different concept. Okay. Different functions of a switch like a MAC address learning, packet forwarding kind of stuff. Yeah. Guys, some people has a question that is switch is a layer 2 device. Switch is layer 2 device. Remember always, switch is a layer 2 device. Hub is a layer 1 device. Router is a layer 3 device. Some people may say like, do you know multi-level switches? Multi-layer switches. Okay. L3 switches. Of course, guys, switch is a layer 2, but there is a layer 3 switch is also there. Okay. Layer 3 switch is also there. What is the layer 3 switch? It is work like a switch as well as a router, mainly for inter-VLAN routing, VTP configuration purpose. Okay, so that is L3 switches. Next, guys understand hub switches, differences, MAC address table. Nothing, people are dropping. What happened today?
Yes, sir.
Okay. The router. What is a router? Router is a inter-networking device. The router is a inter-networking device. A router works with a logical addressing. Switch works with a physical address, means MAC address. Switch use MAC address table to unicast the packets. And switch is for LAN communication. Again, what is the router? Router works with a logical addressing, means IP address. Inter-networking device. We can connect to two or more networks. Networks means different network, different logical network or different physical networks. Of course, physically, logically different networks. We can connect using the router. The router is used for both LAN communication as well as WAN communication only. Router is a layer 3 device. Hub is a layer 1 device. Switch is a layer 2 device. Router is layer 3 device. Layer 3 means network layer. Okay. So if you see, this is a router. It is a Hyderabad office router, Hyderabad office LAN. Even these LAN people want to communicate to the Pune branch or maybe New Jersey branch. So how they were communicating? This LAN want to communicate to this LAN, they have to communicate like this only. Like this only. Okay. So the router make you connect from one network to another network. Okay. So router works both in LAN communication and WAN communication. For WAN connectivity, we use these serial ports. For WAN connectivity, we connect one router to another router using the serial port part. Of course, between the fiber optical cables also there. I'm not talking about that part. Okay. So it is like a for WAN connectivity is there, LAN connectivity also there. What is a router? Router is a root. Its name is actually root. Okay. Router comes from root. What is root? Root means path. Router shows best path to reach the destination. Router shows best path to reach the destination. Routers using routing tables to get to know how to reach the destination. Routers use a routing table so using these routing tables, it will know which direction it has to go. For example, from this LAN, I'm trying to reach this network. But how I know how to reach this network? So I will send packet to the router because this is my default gateway. I will send to this router always. And this router will decide the packet has to send this direction or this direction. How it will be known? Because it is contains a routing tables. These routing tables either you can enter manually, it is called a static routing, or it can be created automatically called a dynamic routing. Okay, so what are these dynamic routing? Is a dynamic routing means by using certain protocols, by enabling a certain type of protocols in the router, these routers will advertise their networks. So based on their advertisements of their connected networks, so it will create a network path. And based on the metric calculation of the network path, it will tell what is the best path to reach the destination. What is the best path to reach the destination? So what is these protocols are interior gateway protocols, exterior gateway protocols are there, like a RIP, RIP, EA, GRP, OSPF, BGP, ISIS. These are all the different routing protocols. Okay. So this is about your router. Router is a inter-networking device. Router works in both LAN and WAN communication. Router main purpose is to communicate between different networks, one network to another network. Okay. Router works with a logical address. Router is a layer 3 device. Okay. So the router, actually the path, router shows best path to reach the destination. What is that meaning? Is like you start from your home, you want to reach your college or maybe bus stop or maybe railway station you want to go. Maybe it contains multiple different paths. Which path is best path? So like that, there is a path is best path. Maybe it can be narrow road, but you can reach by 15 minutes. Okay, lesser traffic is there in that one. Alright, another one is a very broad road, so maybe because of traffic. So like that. So number of stops. It's the best path is there, na? So same way we will see. So the router will show you the best path to reach the destination. It will calculate different metrics. So how it will shows the best path to reach the destination is it use certain routing tables inside of the router. These routing tables can be created manually, that is called static routing, or these routing tables can be created automatically by enabling a certain dynamic routing protocols like RIP, ASGRP, OSPF, BGP, and ISIS. Guys, understand router?
Yes, sir.
Yes, sir.
Then we'll go for a modem. What is a modem? Modulator, demodulator. I've written for a FM signal example here for understanding. Okay. So if you have a FM radio, 98.3 Radio Mirchi, okay. So different radios, FM signals are there. They said 98.3, 93.8, okay, 95.7, something like that signals will they will tell, right? So what is that? It is carrier frequency. Our voice is 20 to 20 kilohertz frequency, and they will attach this frequency to the higher frequencies. Why? To travel the frequency to longer the distances. Okay. So then people can able to receive by decoding it. So you are attaching a carrier frequency and sending, that is a modulation, and you demodulate. It means you receive a signal, high frequency signal, demodulate, and you will extract the actual signal. So that is modulator and demodulator. So what is that electronics, like anybody from ECE? So you can think, sir, why sir is teaching this ECE? We already forget about that one. Okay. So don't worry, guys. The point is when you are communicating within the LAN, that's a your LAN related digital signal only. Okay. The signal is we cannot transfer this signal for longer distances. For example, from your LAN, you want to reach google.com, facebook.com, youtube.com. With this type of wires, we cannot able to travel that much. With your strength of the cable or maybe the, with the strength of your signal time, you cannot transfer our data to the longer distances. So what they will do it? So we have to use a modem to convert your signal based on the connectivities. So for example, you are using a fiber optical cables. Nowadays, everybody is using fiber optical cable from internet service provider, right? So in a home, you are connecting with a Wi-Fi wireless type of data transmission. But when you are sending your data to the internet via fiber optical cable, something should be convert your signal, right? So that is called a modem. Modem has lot of benefits. Modem has lot of things about a modem. I'm not saying about the benefits. It's like the kind of stuff is there. Modem make you to connect to the ISP. If you are able to connect to the ISP, then only you will get a internet using telephone cable or a fiber optical cables. So then you can able to connect it to internet. You have your Wi-Fi routers, the certain routers having built-in modem features, so you can able to directly connect. Our home Wi-Fi routers are having internally a WAN, means you have your own modem inside. So when you are connected to your ISP, and then you will get connected to internet. Okay. So what is the purpose of modem? Modem make you to connect it to ISP. Okay. So you can store your subscriber username and password there. So when you are trying to establish the connectivity, you need to manually enter any username and password because your modem will send that information to ISP. ISP verifies your subscription and it will connect you or network to the internet automatically. Okay. Of course, in a very olden days, we have internal modems, external modems kind of concept, and now it is we have our own Wi-Fi modem is there. Guys, I told about hub, switches, router, and modem. If you are having, so then we can able to connect to the network, right? Okay. But when you are seeing at your home, you may not see any modems. Okay. There is no modem at all. Okay. You may not see any modem, separate modem is not there. Separate things are not there, right? But actually, if you take everything as one single device while you are arranging, and then you will understand what is this Wi-Fi is doing in your home. So we'll go for this small office, home office setup. Like how you set up a LAN connection, how you set up a network, like that also you can able to take this one. So it will start from the basic LAN, okay? Basic LAN connection. So like a intranet or a basic LAN communication. So I have a devices, then I have a some hub or a switch, okay? I have a some hub or a switch, and I make a connectivity between these devices. This is a simple LAN network I have created. It's a simple LAN network. I have a hub or a switch. Okay. And I have a devices are connected. So A, B, C, D will communicate each other via hub or a switch. So this is one LAN communication. This is you can call it as a LAN. Okay. So it cannot communicate outside of your network anyway. It won't communicate outside of its network because it's a simple LAN communication. For example, I have a wireless devices. For example, I have a laptop. I have a mobile phone. I have a tablet. These are the wireless devices. So what I have done to connect between these devices, what I have done, I use a device called a wireless access point, not Wi-Fi router. I use wireless access point. Okay, this is a wireless access point. So you can connect your wireless devices as a single network. You can connect it. Okay, yes, you can connect it. I am removing because I want to draw a box. Okay, this is become big box. Observe carefully, you will understand. Or if you have a doubt also, you can ask me. So guys, this is what I call it is WLAN. What is WLAN? Wireless LAN. Okay, how it is WLAN? Because I use wireless connectivity. That is wide connectivity, and this is wireless connectivity. Both are private network. Only thing is there I use a switch and wide type of connectivity. Here I use wireless type of connectivity. Devices will communicate through this wireless access point. Guys, understand LAN and WLAN?
Yes, sir.
Yes, sir.
If I make a connectivity between these two things, for example, if it is having some LAN port here and I connected this to my switcher hub, so what happened? These devices will communicate it to our WLAN devices. So it is become, both are become single network only now. Both are in the same office, same home. I have a switch to connect a wide type of devices. I use a wireless access point to connect wireless devices. But if I connect these switch and wireless access point, then everything is become as a single network only. But that is a LAN, this is WLAN, but both are private network only. Okay. Now the thing is not the same time, same day kind of stuff, right? People want to access a few things. For example, they want to check their mail, gmail.com, or maybe facebook.com, youtube.com. Things available in the internet they want to access. How they can able to access? So they need to connect it to the internet. Okay, you want to access, then we need to connect to the internet. That's the first thing. But how? Then you have to take a subscription from ISP. ISP will make you to provide internet service. ISC, ISP. It can be Airtel, maybe Jio, maybe ACT, Hathway. Okay, so it can be anything. Vodafone, U broadband is also there. So you have ISP, Airtel, Jio, ACT, Hathway like this, internet service provider. These internet service provider make you to connect to the internet. Through internet, you can access yahoo.com, youtube.com, facebook.com like that. Okay. You want to connect? You need a modem. You need a modem. What you need? We need a modem. Modem make you to connect to the ISP. Modem is also inside your home, but ISP not in your home, right? So how you connect? You'll connect using a fiber optical cable or a telephone cable. Old BSNL time and Airtel also use telephone cables for internet purpose for very long time. CFI broadband like that. Now most of the services came to the fiber optical. And another one is your UTP type of cables. That is different. Fiber optical come UTP cable. It is there are having fiber optical plus UTP.
దాంట్లో కూర్చోపోయారు
దాంట్లోనే చూద్దాం బ్రేక్ ఇచ్చాక వెళ్తాను
వేసాను
డిగ్రీ పెట్టేసింది ఫైల్ ఉంచేసాను సారీ గైస్. Okay, so from ISP to your modem, you'll get internet. From ISP to your modem, you'll get internet. Okay, but that is a public part of network. That is public part of network. But that network you have to connect it to your local network. This is a different network, and this is different network. So you want to connect this network to this network. This is a different network, and this is another different network. Okay, so your modem received internet and it want to connect you to directly to internet, but you are already having multiple devices. Okay, but you want to connect, but how to connect? How to connect two different networks? You have different networks. Which device you will connect? Okay. We use router. What is the purpose of router? It connects between different networks.
So when you want to convert a 2D to 1D,
You tell me. Okay, so this router
Yes, sir.
is connect between different networks. This is your local LAN network. It's your local network. It's one kind of network. And this is public network, different network it is. You want to communicate from this network to this network. So we need a router in between. Route your network from here to outside of your network. That's we need a router. When you see an IP address, CMD, IP config. So you can see that there is a default gateway. You have an IP address and subnet mask, and there is a default gateway. What is this default gateway? For example, you want to communicate from here to here. You don't require any gateway. Or you want to communicate from where it is, from here to here. You don't require any gateway. So in your IP address also, you don't require to mention default gateway. But this time we are communicating outside of the network. For example, from here to outside, you are communicating It means you have, if you want to access gmail.com, you have to go through this one only. So what is this? This is what we call it as default gateway. So the default gateway or default gateway. What is a gateway? So gateway means which place you're actually, which is the what interface or an IP address we can able to go outside. So that is a default gateway. Router act like a default gateway towards your LAN. The router interface IP address is default gateway IP address. Okay, towards you. For this network, for A, B, C, and this laptop and mobile, and what is the gateway is? This is the gateway, default gateway to communicate outside of the network. You should go through the interface, right? That is a interface. We call it as default gateway. And your router interface for your LAN is your default gateway. The IP address of the interface is default gateway IP address. Okay, what is default gateway IP address? Your default gateway interface's IP address. Okay, this is nothing but your router IP address. Of course, router has two interfaces. One is towards LAN and another one is towards internet side, WAN. Okay, towards LAN, towards WAN. This is for WAN connectivity. This is for a LAN connectivities. Okay. So how many devices I told? Modem, router, switch, hub, wireless access point. I told about wireless access point also here. Guys, understand how we are connecting to internet? Okay. So here it is. Hub and switches, wide devices, LAN communication. Wireless access point. That is, again, I didn't cover earlier, but now you will understand what is a wireless access point to connect devices wirelessly. Wireless type of devices you want to connect. So then it is we use wireless access point and you create a WLAN, wireless LAN. Router, internet networking device to communicate between different networks, means different LANs, different WANs, different LAN and WAN. Modem connecting to your ISP, so you can connecting to internet through the telephone cable, fiber optical cable, or any other twisted pair cables also possible. What is ISP? Internet Service Provider. Maybe you will search at home, find out where is the hub, where is the switch, where is the wireless access point, where is the router, where is the modem, but still you are getting internet from your Wi-Fi router. You only having only one device, right? So how it is possible? Because your Wi-Fi router is your modem, because your home Wi-Fi router contains built-in modems, routers, switches or hub inside, okay, for connecting. It also it's a wireless access point. So your Wi-Fi router is not our home Wi-Fi router is not a pure Wi-Fi router, it is, because it is built-in modem, router, wireless access point, and hub or switch it is. Okay, and your Wi-Fi router is also act like a default gateway to connect your network to outside of your network. It is also act like a DHCP server. When you connect it to your Wi-Fi router, so you will get an IP address without using any DHCP server separately. So you will get an IP address from your Wi-Fi router. DNS server. DNS server, it also act like a local DNS server for your network. This is little separated. What is that? See, this is a cable from internet service provider, fiber optical cable. Then this is the fiber optical modem. Okay, optical fiber modem it is. See, the connection is went here, and this modem is now connected to your Wi-Fi router. Then inside this Wi-Fi router, or maybe in this modem, you have to connect. You have to configure about WAN. In this one, you have to configure about both WAN, LAN communication. Okay. So you are getting internet to modem, modem to your Wi-Fi router, from Wi-Fi router to our devices. So this is one picture only. Okay. Guys, understand small office, home office kind of stuff. Nothing, no response anyway. Okay, take a break, guys.
Sir,
Come
yes,
back
sir,
at,
we got it.
yeah, come back at 4:30. Take a break, and we will start OSA model. Okay, I will discuss. Ah, 4:30.